Hello and welcome back to Geometry. We're in Chapter 11, Section 4. We're looking at three-dimensional figures. So we are looking at two different types. One of them are polyhedrons or polyhedra. A polyhedron is made up of polygons as its faces. So the face is a flat surface that has straight sides, that has edges, and where several of these edges meet, we call that a vertex. Now there are 5 ways in which you can have regular polygons assembled to create a polyhedron. And those are called the 5 Platonic solids because Plato discovered these ways. Regular polygon meaning that every side is the same and every angle within it is the same. So I have a particular affinity for these because I have almost every one of these as a twisty puzzle. This is the pyraminx. This is obviously the Rubik's Cube. Here a face-turning octahedron. And this is the megaminx. The only one that's missing from my collection is the icosahedron. And there's not currently a mass-produced icosahedron. A few people have created one, but currently not available for sale. Sad face. Alright, so polyhedra or polyhedrons, both of those are plural form of polyhedron. We have polyhedrons and not polyhedrons. If there is a circular surface anywhere on it, or anything's round on it, then it is not a polyhedron. Okay, that's how you can distinguish those two. Alright, let's look at these 3, tell whether they are a polyhedron. Yes, yes, no, because round surface. Okay, now it says if it is, name the polyhedron. Now, polyhedrons are named for their bases. Okay, so this is a prism. Okay, a prism because it has 2 opposite and equal bases, and it is a rectangle, so it's a rectangular prism. This is a pyramid because all lateral surfaces come together in one point, and it has one base. This down here is the base. So one base, and all the other faces come together in one vertex, so that is a pyramid. And what type of pyramid? It is again named for its base. It has 1, 2, 3, 4, 5, 6 sides, so it is a hexagonal pyramid. Alright, now if you slice through a polyhedron, then you get what's called a cross-section. Now you can slice through it like horizontally at a right angle. If you slice through a cube at a right angle, your cross-section is this in here, this square. If you slice through it diagonally, the diagonal is obviously longer on a cube than one of the edges, so it results in a rectangle. Now if you go at an angle, if you tilt it, and then you could end up with a triangle as your cross section like that. Those are some examples of cross sections. So we're going to look at these and say, what shape is our cross section here? If I cut through it this way, I have a cross-section that seems to be parallel to one of the bases, so the cross-section is a hexagon. Here, again, it seems to be parallel to the base, so we have a shape that matches the base, and that is a triangle. In this case, slicing through here, notice that gives me an edge up here that's straight. This is straight. Down here, this edge is straight, and this one is straight. Okay, if this is a cylinder beforehand, then this is a right angle here, which means that's a rectangle. Oh, not a rectangle. 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 Here we have a circle. Circle. There's a circle. And here, because we're at an angle here and we're past this corner, so this doesn't come to a point. It's not a triangle in this case. In this case, we have a trapezoid. Trapezoid. Okay, and then finally we're looking at solids of revolution. Revolution means to turn, if something turns around. So if I have this shape, a rectangle here, and I turn that around. So I start turning this around, the shape that it leaves behind. Let's say it was to multiply and multiply and multiply. Okay, it leaves behind, as I'm turning it around, a cylinder. So around this axis, which is called the axis of revolution. Alright, sketch the solid produced by rotating the figure. Alright, so if we rotate this around, okay, we're going to go around this way, around in a circle, and that means this side goes around the same way, and this is behind. Connect these, and that gives us a cylinder. Okay, and then here, if I turn that around, then we end up with a cone. Cylinder, cone. Cone. And that's all we have for today. Good times in the Matherhood.